Hi guys, I'm going to do one video for UDP. Normally I split up the client and the server into two separate videos, but because UDP doesn't really have that much in the way of functionality, like built in, there's only like a couple of functions, we don't really need to cover that. I will link up there, up there. There will be a link up there to the playlist for networking. So if you want to sort of get the basics of networking, all that kind of stuff, if you're coming to this video fresh, hi, my name's Sloan. Then the video up there, the videos up there will help you. If you are used to this, then you could probably just skip ahead past this, the introduction bit, and there's two sections. I'll put the time codes in the show notes below, along with all the source code as well, which is in the Bitbucket repository. So yeah, there's not really, I'm kind of stalling here because there's not much to sort of show here. I will be building on this though, because I have an idea for a Boot Hill type game using UDP and Unity. So I will be doing a sort of a Unity version of this video as well, for all you Unity aficionados out there. And yeah, on with the show, I guess. So I'm gonna flip down to here. So what I've done is I've actually created two projects. And you can see down here you've got UDP server and UDP client. And so I'm going to go ahead and create a new item inside here. So this is just a standard C++ project. If I go to File, New Project, what I'm actually doing is I'm going to Visual Studio Visual C++. I'm choosing the console application, and then when you click on Next, it comes up with a wizard, and it shows that you've got the Windows application, console application. You want to choose the console application, and you also want to make sure that empty project is selected. And that's it. What you'll end up with is you will end up with this blank in here. Oops. So what you'll end up with is you'll end up with the blank one here. Alright, so I'm going to create a new item, and I'm just going to call it main.cpp. And we're going to go ahead and just add all the headers and so forth that we need. So I'm going to sort of bring this up a little bit. Include IO stream. So we'll need IO stream because we need to output to the console at some point. We also want to include WS to TCP/IP. So WS to TCP/IP, that gives in all the function headers that we need for the Windows sockets library. But we also need to bring in that library. Now what we can do is we can go to right click, choose properties, and then we can go to linker input, and then there's additional dependencies in here, and we can choose our additional dependencies from the list here, and you see that we don't actually have the one that I'm looking for, which is WS232. So I'm going to include that, and I'm going to use a pragma to do that. If you are using code blocks or what's the other one? The other popular one. There's a Wacom C++ one. The pragma thing won't work for you. You will have to include this library elsewhere, or you can download the free version of Visual Studio, which is the community edition, which is basically it's the entire IDE for free. So it's up to you. I know a lot of people don't, for some unknown reason, like Microsoft, but they give away free stuff for a reason, to get you hooked. So I can sort of see what your point is, I guess. But it's free, so you might as well use it. That's my personal opinion. I've been a bit of a Microsoft fanboy for a while, although I use other operating systems as well. So we want pragma, and we want to add a pragma comment, and the comment is going to be a library, and we want to include w2.lib. So that is what we want to do. So basically what that does is it does the whole right click properties add inside there. And then just for fun, we're going to use our using namespace std. And this saves us from typing std cout, etc., etc., etc. So yeah, just to save us more than anything else. I'm not going to take any input whatsoever for the server, so I'm just going to leave that as main. So we want to, this is for the UDP server, we want to start up WinSock. We want to, what do we want to do? We want to bind socket to IP, res and port, enter a loop, and then inside the loop what we want to do is we want to wait for a message, display message and client info, and then we want to be good citizens. We want to close the socket, shut down WinSock. Okay, so this is our sort of laundry list of things that we want to do for our server. So to start up WinSock, we're going to create data. So this is our WinSock data. We need to pass that in. We also need to pass in the version number we want. Now we want version number 2. The hint is up there. WS2. We want WinSock version 2. So I'm just going to actually let's do it separately. So I'm going to say word, and I'm going to call it version equals make word, and then I can't remember which way around it is, whether it's 2.0 or 0.2 for this. So I'm just going to do 2.2. And in that way, it'll pick up the version that's closest to the one that we want. Int, and then we'll call this one WSOK. If actually int WSOK equals WSA startup, and then we specify the version we want, so version, and then we need to pass in the address of that data. So if WSOK is not equal to 0, we're going to do cout can't start WinSock, and we want to pass in WSOK. I don't know why that was squiggly there. So that's our startup WinSock. That's all we need to do to start up WinSock. And seeing as how we've got that there, let's do the shutdown as well. So we're going to do WSA cleanup. So there is our startup, our start WinSock, and our shutdown WinSock. So the only thing we have to do now is the bit in the middle. So now what we want to do is we want to create a socket, and then we want to bind that to the IP address that we want to use. So I'm going to do socket, we'll call it in, let's call it in equals socket, because that's the function we use to create a socket. And then we're going to specify the address family, the type, which is going to be a datagram socket this time. Normally we use sock stream, which is a TCP socket. This is a UDP. So UDP, again, it's in one of the videos up there, but basically UDP, the packet is not guaranteed to arrive, and there's no control mechanism for when it does arrive. So you could have 5 packets and they could all, appear out of sequence, and you have no control over that. So you need to then do something with that on the other side. When you receive those packages. Whereas TCP, it says, okay, I have packages 1, 2, 3, 4, 5. I'm going to wait until all 5 have been delivered, and then I'm going to combine those packages and then send them off. If it doesn't get package 4, for example, so 4 is missing, then it requests 4 again. And so it waits for the full message, whereas UDP doesn't do that. That's the sort of major difference. The other difference is that setting up and receiving is a lot simpler for UDP, and then we'll just leave that as 0 for that. Now I want to bind to the socket, so I need to have a socket address info, socket address internet I should say, and I'm going to call this server hint dot address is equal to address any, except I can't do that. I've got to do dot sun dot address. Yeah, that's it. So that address any just says give me any address. It doesn't matter what it is, just whatever address the IP of my card that I'm using, my network card I'm using, just give that to me. Server hint dot family equals AFINet because we're using version 4. Server hint dot port equals, and then we need to do our conversion again. Convert from little to big endian. And again, the introduction to networking video shows a bit about the little to big endian bit. And I think that's everything. Sorry, I just hit the mic. Okay, let's try and bind the socket to the hint structure now. Remember that the binding says, okay, I have this logical number, this socket. A socket is just an integer. That's all it is. You can see there it's just mapped to uint. So it's an unsigned integer, which means it's a value between 0 and some very, very big whole number. So binding that number to the socket, to the port and the IP address is what we do in this step here, and that means that any communication that comes in on that IP address on that port goes to the socket, and we can read and write to that socket. It's like it's like when you go to the butcher's or the deli counter. If you're in North America, you go to the deli counter, you pick a number. That's your number, and that's the number that then gets the person then interacts with, and then someone else takes a number. That's kind of the same idea ish. So I'm going to say if bind, and I'm going to bind the socket to, we need to pass in a pointer to a socket address, which is going to be our server hint, and then it's going to be size of server hint is not equal to socket, what is it, 0? Actually, it is going to be equals socket error. So that should be -1. That's right. We're going to do cout can't bind socket WSA get error end line. And we'll just close that there. So that's us. We've bound the socket, and sorry, I have my hints down here. We also need to know about the client as well. So I'm going to create another hint structure, and that hint structure is going to be the client that connects. So I'm going to say socket address in client 0 memory client size of client. Okay, so that's me created my space for in there. I also want to create a space for the buffer as well, so I'm going to create a character buffer. Character is just a bunch of bytes. I'm going to call it buff 4096. Actually, let's make it 1024 because it doesn't need to be 4K in size. Then we do the same thing again, 0 memory and then buffer and 1024, and you can create constants for this as well. So this is the client information. This is the client that connects to the server, and then this is the buffer where the message gets received into. And now we start our loop, so we can do while, and we'll just make this as being true. So really these lines here won't ever get hit, but it's good to have them in. Close socket, and then we pass in our in socket, and that closes our socket there. So the only thing we have left to do now is wait for message and then display the message and client information, and keep doing that until we get a loop. So we don't have a direct connection to the client with UDP. UDP just, you get a message in and then you decide to do something with it. So it's a good idea that you have some kind of unique identifier with the client that connects, and then send that back to them, and then they can then pass that to you. So we'll discuss that more when we get to the Boot Hill game that I want to build for Unity. But for now, we're just going to display the information because it's just a quick and dirty kind of message that we're sending here. So I'm going to enter the loop here. So we're going to wait for a message. We're going to say int bytes in equals, and then we're going to use receive. So there's two forms of receive. There's a receive, which is what we've used before for our TCP client, and then there's a receive from, which we're going to use for our UDP client. So it uses exactly the same way. So we're going to use the socket. So our socket is in, our buffer is buff, our length of a buffer is 1024. And then our flags is 0, and then we have this optional thing here, which is the socket address from, and then the from length. We also need to do that as well. We also need to do int client length equals, and then it's going to be size of client. So really what we should do is we should put that there, client length. And while we're at it, we should also take this out here and put that in there, because we want to zero the buffer every time we receive it, so we don't end up getting junk in our buffer. So we're going to pass in sock address client, and then we're going to pass in our client length, and we need to make that an ampersand as well, and that's us. I'm just going to move this over just a little bit so it's kind of centered. And I'm going to say if bytes in equals socket error, cout error receiving from client. Maybe I say get last error. It's probably not the end of the world, so I am just going to continue. Because I'm not really concerned, it probably is okay. And now I want to display the message and client information. So I'm going to display the message just now. Actually, no, I want to do the full thing just now because I want to build the client later on. So what I'm going to do is I'm going to create another buffer, char, client IP, and I'm going to make that 256 characters in length. And I'm going to do 0 memory, client IP, comma 256. And now I'm going to get information from this call here, because this says receive from this socket into this buffer, and that's the length of the buffer. This part here says take the client information, the client that sent that, and put the information inside here. Okay. And so now we have information about the client that connected. So I can now do inet pton, no, it's ntop, because I want to take that number and I want to convert that to an address. So I want to say it's the AF inet, so I want to specify what format that address is in. So it's in version 4 of the IP address, which is inet, AF inet. The address is client dot SYN address, but I need to specify the address of that field, and then I want to specify the buffer client IP, and then I want to specify the size of the buffer, which is 256. So hopefully you're following that. So basically I want to get the information out of here, which is in a series of bytes. So it's going to be 127.0.0.1, which is bytes, which is 4 bytes. And I want to convert that to a string, which is 127.0.0, which is what, 4, 5, 6, 7, 8, 9, 10 bytes in size. So now I'm going to do cout message received from, and then I'm going to do client IP, and then I'm going to do buffer. And that is going to be my output. And hopefully that will compile, and then we'll review the code. And then once we review the code, we'll then move on to the client. So we're at, what, 24 minutes just now, equals. Okay, so the first thing we did was we started up WinSock, and then once we had, can't start WinSock, we need to do return there, so we don't ever come out of that. So if we can't start WinSock, it's fatal, we need to get out of there. And we also did a corresponding shutdown WinSock as well at the bottom. The next thing we wanted to do was we want to bind a socket to the IP address and the port. So we created our socket. So this is our creating a socket. We were going to use it for datagrams. So it's our UDP socket and not a TCP socket. So that's why we use dgram. We created our server hint. So we specified that we wanted any IP address. So in other words, we want to use any network card on the machine to get out to the network. But we do want to use port 54,000. And unfortunately, because the PC is what's known as little endian, we have to convert that to big endian, which is what networking is used, which is why we use htons, which is host to network short htons. And there's also the corresponding one, which is ntons, which is network to host short. And then we try and bind that socket to our IP port number combination. So now we have a socket which is connecting to an IP address and a port. So that's our like tuple. We have our 3 things there that are connected to each other. Then we set up some memory that we're going to use for our client connecting. So that's the client information is going to go in there. And then we have the message from the client that's going to go in here. So we have 2 separate bits of information. We have, this is the metadata, if you like, for the connection. So this is the client that's connecting, and this is the actual data that the client sends. So when they talk about, the NSA knows about the metadata for certain things, this is kind of what they're talking about, is they know that they know what client connected there. They might not necessarily know what the message is, because it could be encrypted, but they certainly know who connected to whom, and that's kind of free-form text, if you like. Or at least it will be when we go down a little bit. So, sorry, we want to 0 the memory in there. And then once we've zeroed the memory, we can then receive from the remote client anything that they send us, and we put that inside the buffer. And we also get the metadata. We also fill in the metadata here. So this bit here fills in the buffer. This bit here fills in the buffer, and then this bit in here fills in the metadata, the client information that gets connected there. And then we display that information. So we have to get the client information out of there into a printable form. So that's what we use this for, which is inet ntop, which is the number to string. So it's number to pointer to a string. That's what that means, ntop. And there's also an inet pton as well, which is the opposite direction, which I think we've used in one of the other videos. And then we display the information in the message there, and then close the socket down. And that's us. We've got everything there. So we could compile it, run it, and it does nothing. It does absolutely nothing. Oh well, yeah, you might get this. Don't worry about that. This is our code. We know what it's written, so we can trust it. So you just click on allow access, and then it'll go away, and then it just sits there and waits for us to write our next piece of code, which we're going to do just now. While we have the server running in the background, I'm going to go ahead and create a new class. So this is going to be a new item. And I'm just going to call this main.cpp as well. And there's a lot of similarities between these. So I'm going to borrow some code here. So I'm going to grab the first bit here. And then I'm going to copy it and paste it into here. And you see that we have kind of similarities. The only differences I want to add is int argc and then char star argv. Now what this does is this means we can pass in a command line option. So we can actually pass values in through the command line. And similarly we also need to do our WSW cleanup down there. In sock. Okay. We're going to go and create a hint structure for the server. We are going to write a message. Actually, we're going to do a socket and then creation, and then we want to write out to that socket. Close the socket, and I think that's it. That's all we need to do. So create a hint structure for the server, so that the sock address in server, the address is, we'll come back to that in just a sec. The family is AFINet, server.syn port equals, and then it's going to be htons 540, because that's our port. And then we're going to use our inet pton, which takes our string to network, and then we're going to specify AFINet, so it knows what version of the format of the string is going to be. The actual string itself, which is 127.0.0.1, because we'll only be running on localhost. Again, this is a very basic example. We'll get to connecting to remote servers rather than just to the local host. And then we want to specify the buffer, which is going to be server.syn address. And that's it. So that is our hint structure for our server. We're connecting to port 54,000, and then we're going to do that. So the socket creation, socket, we'll call this out. And then we'll specify the family, so AFINet, the type, which is going to be sock dgram, and then our protocol is going to be 0 again. And this is where it gets super simple. We don't need to connect to it. We don't need to do anything else. We just need to write out to that. And how do we write out to things? We use send. So we can do int send OK equals send, and we have this function here, send to. This is the, we've been used to using send, which sends information, and we use that for TCP. We can use send to, and then that will send UDP. So we're going to use our socket, which is going to be out. We're going to specify the buffer, which is going to be our arg value here. So I'm going to make things a little bit, should I make things a little bit easier? Yeah, let's make things a little bit easier for ourselves. String. Okay, so I'm going to say if our, no, it's okay. S, and then we're going to pass in argv1, So argv1, argv is just the argument value. So this is the number of arguments, and this is the value of each argument. So every time you do hello space world, like if you did hello space world for the command line arguments, you'd have 2 command line arguments. Actually, you have 3 command line arguments. The first one, 0, is the name of the program. The second one is your first argument, and the third one is your second argument, and so on. So I'm going to specify the output buffer, which is going to be s.cstring. The length of it, which is s.size. And I'm going to add 1 because we want to get the 0 from there as well. The flags are going to be 0, and then the address is going to be socket address. And then we specify the server and size of server. And we need to put in our ampersand there because it's in the address of the server. And if we want to say if send OK socket error, cout that didn't work, WSA get last error. So something like that. And then we'll do close socket, and it is out. And that's it. That is the client. That's all we need to do for the client. Now, how do we test this? You notice that I have my server running in the background. I am going to do right click on the property. So right click on the project, choose properties, and then inside debugging, so there's a link here. One of those is the command line arguments. I'm just going to specify test message 1. Okay, so I'm going to call that test message 1. Click on apply for good measure, click on OK, and I'm going to run it. And how am I going to do this? Okay, let's just do this as if it's magic just now. I'm going to run this. And so the program flashes and disappears. And when I go to here, it now says message received from whatever it is, test message 1. So let's do this from Internet Explorer. So if I go into debug, and then I do file, open PowerShell. Okay, so here is my PowerShell, which unfortunately is like a huge big long pad here. So hopefully you'll be able to see this. Maybe I can make this a little bit smaller. Put that there, and then bring this one down here. Okay, so now you should be able to see this. So if I do UDP client, and then I'm going to say this is a test, and then hit return, this should down here display this is a test. And it does. So there you go, we know this is working now. So we get UDP client, another test, you can even use spaces. Okay, so you can use spaces because you put it inside quotes there. And that's it, that's TCP. And we'll be dealing with TCP a bit more later on, but not this year. More of that in just a sec. Hi guys, thank you very much for watching. Hope everything was anyway, if you're any confusion or whatever it is that I wasn't explaining it very well, or you have more questions, whatever, leave a comment below. This is probably going to be the last video for this year. What can I say? It's the holidays. So I hope you have enjoyed the videos this year. The video a day in September, I'll probably do, actually I'll probably do like a kind of roundup of maybe in January of what happened this year, but I don't think I'll be doing a video a day ever again. That was a lot. But anyway, I hope you enjoyed this video. especially the sort of two-part thing. There's not really that much. I mean, this is a fairly long video now, and I'm going to have to do some editing for it. But hopefully you enjoyed the video. If you did, thumbs up. If you didn't, thumbs down. If you did like the video, feel free to share with friends, family, colleagues, all that kind of stuff. I have many other videos here that you might be interested in, and there's many more videos coming down the line. There's a lot of suggestions from you guys as well about videos. In fact, this was actually one of the suggestions, was to cover UDP, which I haven't done before in a video. So if you didn't like, don't just leave a thumb down. Just let me know what you didn't like about the video. That would be great. It would help the channel out and so on.